We're going to be solving systems of linear equations. So what are systems of linear equations? A system of linear equations consists of two or more linear equations made up of two or more variables, such that all equations in the system are considered simultaneously. To find the unique solution to a system of linear equations, we must find a numerical value for each variable in the system that will satisfy all the equations in the system at the same time. Some linear systems may not have a solution. Others may have an infinite number of solutions. For a linear system to have a unique solution, there must be at least as many equations as there are variables. Even so, this does not guarantee a unique solution. So, you've probably only done systems of equations with two variables. If you'll remember, when you did it graphically, you're basically graphing two lines, and you're looking for the point where they intersect. They could have one solution. They could have no solutions. They could have infinitely many solutions, right, if it's the same line. So those are the three possible outcomes when you graph them. It's very visual and easy to see. After you got done graphing them, then you did it by substitution. You guys remember solving systems of equations by substitution? You isolate a variable, you plug the variable in, and you simplify. And then you also did it with elimination, where you can multiply one or both of the equations to make either the x's or the y's cancel out. And then you simplify from there. So we're going to briefly talk about all three different kinds, but you can really solve any of them any way you want to. Here's our three possible outcomes. We talked about them being one solution, no solution, infinitely many solution. They actually can have different names. So in 112, instead of saying one solution, we say it is an independent system. So that's because there's only one answer, so it's independent. Inconsistent means there was no solution. And then if it's the exact same line, we call that a dependent system of equations. So 3 new vocabulary words, and they will ask you those on the homework. So you can always go back to this page and reference it to know which is which. Independent, inconsistent, and dependent. All right, so I'm at the top of that page. You see here, how many different equations does it give me? It gives me 2 equations. How many different variables are there in those equations? 2. So what it said at the end of that last page is, if there are 2 variables, you need at least 2 equations to solve it. We're going to have some later that have 3 variables. If you have 3 variables, you need 3 equations to be able to solve it. So however many variables there are, that's how many equations we need. So if I had to solve this system of equations, for me personally, because the x's and the y's are already on the same side, I would use elimination to solve this one. So let's do a quick review here of how we solve systems of equations using elimination. To me, I think it's the most fun one anyways. So in order to eliminate, I need an x or a y to have opposite coefficients. So I'm always looking, are any of them opposite already? Well, this is a -3 and a +5. They are opposite signed, but these are not the same number. Here, these have the same number, but they're not opposite signed. So I think the easiest thing to do here would be to make the top equation have a -y. So we could multiply it by -1. Because remember this, does that seem somewhat familiar, hopefully? Not at all? Using elimination? So, okay, so let's talk about what this means then. So if I multiply everything in the top equation by -1, that gives me a -y, a +3x is equal to 4. Everybody's okay with that? This is at the top of that. Did you have the picture? Or no? I'm still on page 2. You're good. Are we okay right here? So here's what eliminates. Now I'm going to combine the equations. So what that means is combine y with negative y. Well, what is y minus y? Cancels. That's the whole point of elimination. I need that to happen with one of the variables. Now if I combine 5x and 3x, that gives me 8x. 12 and 4 gives me 16. We okay with that? Now, what have I done? Now I've written it as a single equation with only one variable. Can I solve for that one variable? It's being multiplied by 8, so we divide by 8. So the x value where the lines meet is 2. But we're not finished because remember, the point that they're intersecting is an ordered pair. So all I know is the x value is 2. In order to find the y value, I must take this 2 and plug it into any of my original equations. So I'm going to plug it into the denominator. Or not the denominator, the bottom equation. So that would be y equals 5 times x. I know x is 2 though, equals 12. No, it shouldn't be equals. I'm an idiot. Y, I'll get better in a second. Y plus 5 times 2 equals 12. So this would be y plus 10 equals 12, which means y equals 2 if I subtract 10 from both sides. So what have I found? This would be an independent system. It has one solution. That means they cross. Where is it that they cross? They cross at 2, 2. I've never had the heat on in here. So here we're given the systems of equations, and they're asking me, is 3, 4 a solution? So if 3, 4 is the solution, that means what? 3, 4 is the point where the two lines intersect. So it's going to make both equations true at the same time. So we could solve the system using elimination, substitution, or graph them. But if it already tells me what it thinks the solution is, we can just plug that in and see if it makes both of them true at the same time. So this would be 3 minus 4 times 4 equals negative 14. So 3 minus 16, does that equal negative 14? And 3 minus 16 is negative 13. So does negative 13 equal negative 14? No. So is this the solution? No, it's not. Questions there? Second one, very similar. Is 417 a solution? I can take this and I can plug it in to the top equation. This would be 3 times y, which is 17, minus 18 times x, which is 4. Does that equal negative 21? That would be 17, 34, 51, minus 18, 36, 72. Does that equal negative 21? Negative 21 does equal negative 21, so it works for the top equation. Did I do that too fast? Just because it works for the top one, though, that's not enough. I have to also then plug it into the bottom equation. It has to make both of them true at the same time. So 2 times y, which is 17, plus 7 times x, which is 4. Does that equal 45? 2 times 17 is 34. 7 times 4 is 28. Does that equal 45? No, it doesn't. Okay, here it tells me to solve these by graphing. So we're going to do graphing this time, just because it asked me to. I would typically use substitution here. Now, when you graph by hand, let me show you some of the downfalls with that. You definitely probably need to use graph paper because you're looking for an exact solution. And so you need to make sure you keep it to scale. And then both of these are already in slope-intercept form. So the top equation has a y-intercept at -5. Plot the point. The slope is 1. Rise 1, run 1. Rise 1, run 1. And then I can draw that line. Let's see if I've learned how to use this line tool. Nah. Okay, and then the second one, y equals -x minus 1, has a y-intercept at -1. Slope is -1, so we're going down 1, right 1, down 1, right 1. And if I graph that one, somewhere like that. And so the solution to the system of equations is the point where the two lines intersect, which is at 2, 1, 2, -3. And again, if you're ever unsure, you can plug this in to see if it makes both of them true at the same time. So does -3 equal 2 minus 5? It does. Does -3 equal -2 minus 1? It does. So because it makes both of them true at the same time, it is the solution to the system of equations. That seemed familiar, maybe? So graphing was good, but elimination was not familiar? Oh, no. Why? Okay, it tells me to solve this one by graphing. I would not graph these. Do you know how you do this if you had to graph them? Yeah, that's 100% what I would do. I would use elimination because the y's eliminate right off the bat. Right? Elimination will be so easy here. So I'm going to do elimination, but I'm asking if you had to graph it. Yes, you need to get both of them in slope-intercept form. Get the y by itself, and then graph. Okay? Let me just do graphing because I think I know. Well, yeah. Let me just do the graphing. I think I know where this is going to go. So if I did graph it, this would be 2x plus 25 equals positive 5y. And then if I divide by 5, that's going to give me y equals 2/5 x plus 5 for the top one. Is everybody okay with that? I'll move my -5y over to make it positive. Then I move the -25 over to make it positive. In the denominator, or why do I keep saying denominator? In the bottom equation, I would move the -4x over. It becomes positive 4x. Then I would divide by 5. So that would be y equals 4/5 x plus 7. Okay, and if I were to graph these, so again, you know how to do it on the calculator. The calculator would work really great here once you get to this point. But something tells me graphing by hand is not going to work so well. But we'll see. I may be wrong. So the top equation has a y-intercept of 5, a slope of 2/5, which means I want to rise 2, run 5, which would put me there. I could also go down 2 and left 5, which is here. Use my line tool. There it is. Now the red line has a y-intercept of 7, which is here. Its slope is 4/5, which means I need to go down 4, left 5. Oh, it worked out nice. How dare it. So then where do those two lines intersect? It's right there, which is at negative 1, 2, 3, 4, 5, and up 1, 2, 3. Whatever. Okay, now let me show you, if you didn't do it that way, how elimination would work. Because x and y are on the same side, the y's are already ready to cancel. I've got a negative 5y and a positive 5y, so those will eliminate. 2x minus 4x is negative 2x. Negative 25 and 35 is 10. Then I would divide by negative 2. And so the x value where they intersect is at negative 5. Am I going too fast? I know this is negative 5, so I'm going to plug that in for x into one of my two originals. I'll just go with the top equation this time. And so that would be 2, I'm kind of running out of space, 2 times negative 5 minus 5y equals negative 25. So this would be negative 10 minus 5y equals negative 25. Move the negative 10 over, it becomes positive. So negative 25 plus 10 is negative 15. And then divide by negative 5. So the y value is 3. So the point where they intersect is at negative 5, 3. There you go. You've seen it two different ways. You've seen it with elimination and graphing. Questions there? But if I have to solve using substitution, again, if I looked at this equation, how would I solve this? I wouldn't use substitution. I would use elimination. The y's will eliminate, just like that. Okay? But I'm going to use substitution because that's what they asked me to do here. In order to do substitution, the first thing I need is an isolated variable. I need a variable by itself. This equation, neither one of them has an isolated variable. But I see in the top equation, I can very easily get x by itself if I move the negative 6y over. So that would become x equals positive 6y minus 4. Is everyone okay with that? Isolated variable. Now, once I have that isolated variable, this is literally saying x is the same thing as 6y minus 4. That's what an equal sign means. So now I'm going to take that information, and in the second equation, instead of saying x, I'm now going to say 6y minus 4, because they are the same thing. So this would be 7 times x, but x is now 6y minus 4 plus 6y equals 20. So I have taken what used to have two different variables, and now they just have a single y. or there's two y's in there, but there's only a single variable, y. I distribute 42y minus 28 plus 6y equals 20. I've got like terms that I can get together. 42y and 6y is 48y minus 28 equals 20. And now I want to get y by itself. So move the negative 28 over, it becomes positive. So 48y equals 28 plus 20, which is 48. Divide by 48. And so I know the y value where they intersect is 1. I'm going to take this and plug it into any of the original equations. I would always choose this one, where I've already isolated for x. So I can plug in y there. So that tells me x equals 6 times 1 minus 4, which means x is 6 minus 4, which is 2. So the ordered pair where these intersect is at 2, 1. All right, I'm just going to work it, just in case you're stuck somewhere. I have an isolated variable, so I know x is y plus 3. So I'm going to plug that in for x in the other equation. So that would be 4 equals 3 times x. But I know x is y plus 3 minus 2y. Now that I'm going to get the y's together so I can have a single y. So I distribute. Then I combine like terms. So 3y minus 2y is a single y. So we get 4 equals y plus 9. And then subtract 9. And so I'm left with y equals negative 5. Anybody, any questions? Once I know what y is, I'm going to take this and plug it in and find x. So if x is negative 5 plus 3, that means the x value must be negative 2. So the ordered pair where they intersect is at negative 2, negative 5. What did I have to do to make elimination happen here? I would multiply the top equation by 2. So if I distribute that, that would be a negative 6x, a negative 8y equals a negative 20. So when I eliminate, the x's eliminate, the y's eliminate. So what's left on the left side? A 0. 20 minus 20 is 0. So all of my variables went away. Now what I'm left with is a math statement. Does that math statement make sense to you, or is it nonsense? That makes sense. 0 does equal 0. Where does 0 equal 0? Everywhere, always, forever and ever. Amen. This is a dependent system. In other words, this means there are infinitely many solutions. It's the same line. So graphically, if you want to think about it, it's the same line on top of itself. So where do they intersect? A bunch of different places.
When it does that and they don't, like if it says 0 equals 1, is that when they don't intersect?
You're left with a math statement that's nonsense, right? Nonsense, no solution. Makes sense, infinitely many solutions. Did anything eliminate immediately? No. So what'd you have to do? To which one? So if I multiply the bottom one by negative 3, I'm going to make the x's eliminate. I agree, that's what I would do. So 9x minus 4y equals negative 16. And negative 9x plus 9y equals 36. Now the x's eliminate. Negative 4y plus 9y is 5y. 36 minus 16 is 20. Divide by 5, so the y value is 4. So that means this is going to have one solution. So I'm going to take that information, I'm going to plug it into any of my original equations. I would plug into the bottom one, just because I don't really want to deal with that 9. So it's 3x minus 3 times 4 equals negative 12. 3x minus 12 equals negative 12. Add 12. 3x equals 0. Is this okay?
Yeah.
A lot of people freak out, and when they start getting zeros again, then they start thinking, oh, that's no solution, or it's infinitely many solutions. This is still fine. 3 times something is 0. So what's that something? I divide by 3, so x is 0. So the ordered pair where they meet is at 0, 4. Okay, so don't freak out. It's only no solution and infinitely many solution if your variables go away. The variable is still here. So I can keep doing regular algebra with it. Because I have the top equation, I have an isolated variable. So I'm going to give you want me to do it or you want you to try it? Okay, go for it. Are we ready? If I substitute this in for x, that's going to leave me with 9 minus 2y plus 2y equals 13. I combine my like terms. So negative 2y plus 2y cancels out. And I'm left with 9 equals 13. It's a math statement without any variables. Does this math statement make sense or is it nonsense? It's a bunch of nonsense. 9 doesn't equal 13. Silly rabbit. Tricks are for kids. That means there's no solution, which means these are an inconsistent, I can't spell that, inconsistent, oh, it's written right there, I-N-C-O-S-I. I was good so far. An inconsistent system. No, so I would multiply the top equation by negative 3 to make the x's cancel. So that would be a negative 3x minus 9y equals negative 6. Is that right? Negative 3x minus 9y equals negative 6. Then I combine them. This goes to 0. This goes to 0. 6 minus 6 goes to 0. Math statement that makes sense. 0 does equal 0. So this is the same line, which means it is a dependent system. Or the way you used to say that, this has infinitely many solutions.